How are you guys? Our given question 6. This is Feb March 2018 question paper. Our given 6.2 reads as follow: a mixture of 0.2 moles of hydrogen chloride and 0.11 moles of oxygen gas is sealed in a 200 centimeter cube flask at a certain temperature. The reaction reaches equilibrium according to the balance equation for HCl plus O2, right, and give us the 2 chloride gas plus 2 H2O, which is water, right, and then it says it found that 1,825 grams of hydrogen chloride is present at equilibrium. You see, this is at equilibrium. Calculate the equilibrium constant, which is Kc, for this reaction at this temperature. Right, we'll use this rice table. What we are given, we have our reactants here, HCl, also have oxygen gas, right, we have chloride, H, which is the gas. Also there we have some water here, H2O. Then what is our ratio here? We have 4. Here we have 4. Here we have 1. We have 2 there. Of water, we also have 2 there. This is our ratio, mole ratio. Right, so what about initial moles? We are given the initial moles of what? The mixture of 0.2 moles of hydrogen chloride is 0.2 here. It is given 0.2 moles. Initially we had 0.2 moles. Then of hydrogen chloride we also have 0.11 moles. We had 0.11 moles. Then here we have 0.11. Right, then we are not given the products, we know, but the products will be what? 0. Initially we had 0 because of the products. We have started with the reactant is what we started with. The product we had nothing when we were starting. So the imported one is this column. This column is very important. Yeah, the change. This column is the most important one also. Yeah, it's very important, that one. So, but also we know we're given that they say that it's found that 1,82 gram of hydrogen chloride is present at, you see, we're at equilibrium. So here we can find the moles. It will be equal, we'll use the formula, we'll use the formula, we'll have mass over molecular mass. We'll use that formula. Then what the mass, our mass there, it is 1, given the mass there, which is 1,825 divided by this is 1,825 divide this by Okay, we have molecular mass of you go to your periodic table of hydrogen, it's 1, we know that. Of the chlorine is 35 comma right comma 6 30 or 36 35 36 comma 5, divide by that. When you divide, you're supposed to get that the moles actually here will be 0.5. When you divide by that, your moles, go to your periodic table, the moles that you'll get here, we'll find out the moles equal to 0.05. Alright, the moles at equilibrium. So at equilibrium we have 0.05. What about the change? So the change there, what happened about the change, what is going on? So what about that? Here we'll have 0.05 moles. So when you want the change, you're gonna say what? Final minus initial, right? So that's the change. Change is equal to final minus initial. We will say 0.05 minus 0.02, 0.02. There you'll get, here it's negative 0.15. Right, this is what you'll get. Now we'll use the ratios. We have 4 into 1. You're gonna say 0 negative 0.15 divide by 4. You'll divide that by 4. You'll get this is what will be negative 0.0375375. You got this. Fine. So here we have the ratio is 4:2, right? So this is the ratio, 4:2. Is the same as is 2:1, right? It's the same as is 2. It is the same as, so you can say, you see the ratio is 4:2. You can say 4 divided by 2 is, right, is the same as 2:1. We'll divide 0.5 by what? By 2. And right, you'll say 0.15 divided by 2. That will give you 0.075, right? So same applies here. This will be the same, because also here we'll have 0.075. Hopefully you understand the ratio there. The ratio is 4:2. So since it's 4:2, is the same as it is 2:1, right? Yeah, 2 goes into forward 2 times, then here we'll be left with what? With 1, right? So to to have the equilibrium moles here of oxygen gas, we will say 0.11. We subtract the 0.075. When you subtract that, you will subtract these 2. You will say 0.11 subtract 0.0375. Supposed to get, when you subtract these 2, you will get that this is 0,0725, right? Then this you'll just add, this will remain as it is, will be 0,75, this will be 0,075, right? Those are products. That is what we have. Here we know that you'll use this formula for equilibrium concentration. C is equal to N over what? Volume. For that one is 0,05 divided by 0,2. Remember, we're given this in centimeter, 200 centimeter cubed. Then you divide by 1000, you'll get this to be 0,2, right? Then your moles in the first block will be 0,05 divided by 0,2. There you'll get this is 0,25. Same thing here, you'll say C is equal to N over V. You'll take 0,0725, divide that by 0,2. For concentration here, concentration will be 0,0725, divide that by 0,2. What we'll get there, we'll get 0,3625. This is what we'll have since this is what we'll have there. So you can do for the products C, you know that will be 0,075 divided by 0,2. Then find your calculator there, 0,075, you divide that by 0,2, you get that to be, for products here will be 0,375. These are the same value, obviously will be 0,375. This is what we have there, right? So what we want, we're done with the rice table. We want the Kc, constant. So we can calculate Kc. We know Kc, it's a product over reactants, right? So we know that. So we'll have the product of what? Of the concentrations of the product. We'll use the brackets. This indicate the square bracket shows that it's a concentration, right? So yeah, what do we have in the product? We have here 0,375. Let's check. We have 2 there, so you see the 2, our mole ratio is 2. We square this, also we'll have 0,375. we square that, we have 2 there, we divide this. This is the same, this and this are the same, it's the same as power 4 there. If you want, you can write this to be the same as power, but okay, it's fine, let's just write like this. this because this is the same. When you multiply, we'll just take the exponent the same at its power 4. Then our reactant, also you check there before you do that, but we know that we have gas, but if we have solid and liquid, we don't include them on our KC. So we can, our reactant, we have there 0.25. This is raised to the exponent. What the ratio there is 4. Will be raised to the power of what? Raised to the power of 4. Then there we had again we'll have 0.3625. This will be raised to the power. Let's check. We have 1 there, so just 1 is the same as nothing. So yeah, we punch this on our calculator. You can punch all of this. All of these, punch all of this in your calculator, find that Kc is equal. If we punch that, there we have 0.375 squared multiplied by 0.75, right? Then squared all over 0.25 raised to the power 4, multiply that by 0.3625, right? You're supposed to get this, that Kc is equal to what? 13.96 yeah, 6, like this. Wrong.